A webinar on machine learning, deep learning, hands-on experiments. RDBS Geeta Deep Enterprises. In association with Sharad Institute of Technology, College of Engineering, Ichokaranji. Sponsored by Institution of Electronics and Telecommunication Engineers.
Welcome to day 4 session of MLDL webinar. Today we are going to perform experimentation for outcome of each layer in convolutional neural network. Yesterday we have seen how to configure entire network model. Now today we are going to see which layer is significant in what outcome point of view. For this we are going to make utilization of VGG16 model. So how to download VGG16 model into our PIP3 cache, and then how to utilize each layer output, how to see the outputs of each layer, that we are going to understand in this experimentation. So let's begin with the hands-on session of layer to layer outcomes in today's experimentation.
So let's begin with VGG16 experimentation. So type from TensorFlow, Python, Keras, applications. We will call VGG16, import VGG16. Next to that, save it. This the only first line you have to type and save the program. So first of all, first task is to download VGG16 model, just like yesterday we had downloaded MNIST. So here give the name with the extension py and run the program. This VGG16 model is of size around 600 MB, so it is going to take a lot of time to download, as already I have downloaded this on my PC. It is not going to take much time. Here Keras typing error. Okay, so run this file and it will simply go to download VGG16 model. As I have already downloaded, it is not getting into download mode. It will next time use what is already been downloaded in cache of pip environment. So here next thing is from TensorFlow, Python, Keras, applications, A16, import we have to import now pre-processing. So pre-process input, that is again a part already implemented in VGG16 applications. So TensorFlow, Python dot Keras, you have to call pre-processing image, which will import load img. So load img method, then TensorFlow.python dot Keras dot pre-processing dot image, import image to array. Well, VGG16 requires array format of the data, so this model. Next to that, from Keras models, import model to handle structured model type of. Then from matplotlib import pyplot as plt. Next to that, from numpy import expand dims. So this will be required to reshape the data, as input will require reshaping. So now let us define output layers for feature map observations. So as we have planned to check output at particular stages in this VGG16 model, so let us randomly define 2, 5, 9, 13 and last layer 17. So at these stages, what the image outcomes are, you will be able to observe. You can change this to any value. Now configure outputs data to load into our model configuration. So outputs we will assign one by one from IXS matrix defined here. This IXS is nothing but this one. So this is the method of writing for loop in Python. So next to that, model dot summary we are going to print for VGG16. Just like yesterday, it will print all the layers available in the model architecture. Next to that, we are going to load the image. So you are going to load the image that I am going to supply you in the group, WhatsApp group. I will send it to all. Particularly we are focusing on leaf image. This load img basically operation belongs to Pillow. Pillow is already imported in VGG16 applications in Keras. So though Keras we have installed, TensorFlow we have installed, and if we do not install Pillow, this command may not work. Next to that, load img command itself is responsible to reshape the data at the time of loading, not the data image. So we are changing it to 24 by 224. So 001 PNG we are going to load. So once this command gets executed, img will get assigned 001.png file contents in 224 by 224 size. Next to that, img to array we are going to convert. So input image, which is of type image, we are going to convert it into first array data type, not image data type we can handle. So this command we have called. Next to that, whatever we have loaded, the image that we have loaded, whether it is correctly loaded or not, let us check it. So let us run this code. Already we have saved it. So rerun mypro vj16.py. Import here, cannot import name expand indims. Well, we have forgot to, yes, there is a spelling mistake. It's expand dims only, dimensions. Indims is the command used while printing the dimensions of numpy array. So that function we are not intended to call here. Next to that, run. Model is not defined. Okay, so we simply imported VGG16 but forgot to assign it to model. So let us first of all assign model with the structure input output that VGG16 has, and outputs we have already defined. So input is equal to model dot inputs. So the model we are calling from VGG16, whatever its input structure is, that will be defined as it is for input data type in the model, and outputs equal to outputs. So first output stands for argument type, second output stands for the value that we have assigned in the earlier line. Next to that, yes, model we have to define it as a VGG16. So here actual assignment of model is, then we assign outputs with the value, and then we configure model with input output value, and then we print the summary. Okay, so now let us run the program. Here is the model printed. Architecture, we can understand that total 17 layers are there along with input. So you can check input layer, convolutional 2D, max pooling. Then yes, there are multiple such configurations considered for configuring VGG16. So yes, the file is not in the directory, so we have to put 001.png in the same folder to load into our program. So paste simply the file that I will send you on the WhatsApp. Well, this is the only white box it is showing, because we are trying to display NumPy array as an image. So our location of imshow command is after conversion to array. It should be before conversion to array. And now let us run the command. Okay, so our image is loaded. This leaf image I have taken intentionally with the one dot because of a disease. You can Google deceased leaf images and you can take one of them, whichever is available, and you check the things. Also you can observe the axis here. It is indicating 224 by 224 sizes. Next to that, always do remember that starting point of image while plotting into any figure is at the left top corner, though our normal axis starts at the left bottom. While considering image, first element you should consider at the left top, because that is the general understanding while representing any image. So this way how we load the data, then let us reshape it according to required input layer of the model. This comment I am putting just for the reference. Next to that, img equal to expand dims. Now here only one image we are having. Yesterday we were having 60,000 images. So simply we have to convert it into axis 0 data type. So simply this will change the data into 224 by 224 by 3 format. So first here indicates the total number of images, which is irrespective of the total number count we are using at the time of actual input. Then 224 by 224 and 3 is the channel. So as this is a color image, here channels will be 3. Yesterday's images were black and white or grayscale, though they were appearing, or monochrome we can say simply. It may not be necessary that it should be grayscale only for monochrome. Single color image can always consider it to be two-dimensional. Let's pre-process the data using inbuilt functionality of pre-processing that we have imported already. So img equal to pre-process input img. So what is actually happening because of this pre-processing? For that we should understand. For that we are going to print before pre-processing and then after processing this img array data, and let us observe the difference. Yes, here we cannot differentiate actually that which data is where. So let us put mark print here 1 in single quotes as a string, and here 2. So after here 1, whatever is printed will be before pre-processing. After here 2, whatever is printed is after pre-processing. So let's check what it gives. Yes, this is the first element 81.061 and this is 190. So you can understand, due to pre-processing, values of these pixels have been changed or converted into decimal format. So maximum values, maximum details we will get after pre-processing the data. So this is simply the normalization process while giving input to the VGG16 model, as pre-processing has been already been defined by the developers of VGG16. The model is very much popular for classifying different types of classes, up to 1000 classes of the data. Next to that, let us call the model to get the output of feature maps. Here feature maps is the processed output from VGG16 model. So we are going to predict the data, model.predict, and whatever the feature maps we get, we are going to plot into the figure window. So for that we will tie a for loop. Next to that, it will be the nesting of the for loops. So for without any variable in range square. So this will be the square window. So 64 outputs we will plot at a time in a single figure window. So we will use subplot for that. Subplot square comma square comma t. So we have to define square to 8 to get 64 outputs. Next to that, ax dot set x label x tick this way. So empty we are trying to set here, basically to avoid printing of access into the figure window. Next to that, plt imshow fmap 0 t minus 1 cmap is equal to grace. Well, here color map you can define any the value you want. So I will use cool warm red So how it appears you will come to know. If you want to know what are the other types of colors, simply misspell something input to here, so it will print as a error response what are the other possible values in the command window. So there are also blue, green, whatever you want. So here we complete. Okay, there is syntax error. Let's check what is happening. Yes, bracket, unwanted bracket. So rerun the command. Oh, so directly pipeplot we had called, but we all have already defined PLT as an object for this. So yes, so we get each layer output. Actually we should see 64 images. Only wait 8 you are seeing in this. Okay, where the mistake is in the program, let me identify. Yes, one for loop, I think missing. So paste here. Well, indentation you should follow properly in the Python while programming, otherwise error will occur. We want to call plt.show right after completion of this inside for loop. Yes, so now we get 8 by 8 output. So 5 different layers we had defined to see the output of feature map extraction. So let us change it to something, or simply let us check the output of all layers 1 2 3 4 5 6 7 8 9, likewise up to 17, so that you will come to know actually which layer is responsible for what type of operation and how it is changing the input to output. So this observation is very much important while selecting particular method while implementing into our project research work. There is a little syntax error, so we missed something at the time of typing array for 1 to 17. So let's check first. Where the error is. Yes, we missed one number. Okay, So now it should show all the outputs for all the 17 layers. Again, indentation error. What happened? Okay, let's, instead of spaces, let's change it to tabs. Let's shift all the data with one tab. So you can either use tab only or space only. Combination will create such a kind of indentation layers errors. So let's check the output. Yes. First layer, second layer. This is third layer. You can see that how it is going to change one by one at the output of each layer. The image is getting decomposed. Only required or edges or some dots are getting highlighted. So you can understand that why intentionally deceased leaf image is considered, because we want to boost the features of deceased area using VGG16 model as a feature extraction tool in our entire target work. So here we get all the 17 layer outputs. So now the next thing that we're planning is, when we close this, actually we are unable to see actual difference. So let us see the figures using plt.savefig command. According to syntax, first argument is file name. So file name should be dynamic for writing different figure as images. So we will use one variable by converting it into string. With the DPI 300 we are going to save, and extension PNG. So let us define that variable with the value, initial value as 1. So we should be able to get 17 images saved in our folder, and for every iteration it will increase by 1. So now run the program, and we can see that yes, first figure is launched. Let us check whether image has been saved in our folder. Yes, out1.png has been saved. So close the window. Second is also been saved. Third. So likewise 17 images we are able to save in .png format. We have to wait until all the 17 images are being saved, and plt.show command is responsible to launch figure window and hold the output. So unless and until you close that figure window, next figure window will not launch. So to avoid this, you can finally at the end you can call plt.show instead of in a loop. but this helps to observe individual output. So let's see how the image is saved. Yes. Now this is first layer output. This is second layer, third, fourth. So you can see the difference, how the output is changing. Max pulling and all is responsible to pull the pixels. So this is final output. So here you can see most of the dots highlighted in second last layer. So
we have seen how to download VGC 16 model, how to configure or how to write a code to run using VGC 16 model. We have seen the outputs of each stage block by block to enhance the feature set of a particular image. We have tried experimentation on leaf image that we have used manually, and after that we have seen that how to convert our features map extracted from this convolutional neural network into a single dimensional vector. Now tomorrow we are going to see how to use these vectors in classification stage. Thank you.